All right. So these ones are some pretty specific examples, or like, I guess, unique examples is a better way to say it. These are called difference of squares or difference of two squares, you might hear. It says the first term will be a perfect square, the last term will be a perfect square, and there will be no middle term. You can think of that as a 0x in the middle if that helps. The difference of squares will always factor as two identical factors, except one factor has a plus and one factor has a minus. So basically what they're saying is x squared plus 0x minus 16 is what we have right here. So we're looking for numbers that multiply to negative 16. So their signs must be opposite. So like 1 and negative 16, negative 1 and 16, negative 2 and 8, 2 and negative 8, 4 and negative 4. But they also need to add to 0. So we would end up with x minus 4, x plus 4. But what this little chunk up here is saying is if you can recognize that you have a perfect square here and a perfect square there, and that there's a minus sign in between, you can just square root the number at the end, or square root both parts. So let's look at this one and use a quicker way. What's the square root of 64? Well, that's 8. And it says one factor has a plus, one factor has a minus. So it's x plus 8, x minus 8. If we move to this one, square root of 1 is 1. And we say x plus 1, x minus 1. This one, we have a perfect square in the front, a minus, and a perfect square in the back. So the square root of 25 is 5. So we're going to say 5 plus x times 5 minus x. The reason this goes on the back side with the plus minus is because that is the thing that follows the negative sign. So this one follows the negative, that's why it's plus or minus that. This follows the negative, that's why it's plus or minus 4. This follows the negative, that's why it's plus or minus 1. This follows the negative, so it's plus or minus x. All right, same thing, just looks really complicated. Here we have a perfect square, perfect square, perfect square, and we have a minus in the middle. So the square root of 81 is 9. Square root of x squared is x, and the square root of 49 is 7. So we get 9x minus 7 times 9x plus 7. Again, this follows the negative, so we do plus or minus 7. All right, here we have a perfect square, perfect square, perfect square. Basically, we just need to take half. So you'll notice here x squared became just a single x in both of these. Same with the last page. So here, if we have x to the 4th, we cut that in half and we get x squared. The square root of 25 is 5, and half of y squared is y. This is what follows, so it's going to be, again, x squared plus 5y. You guys can always put it back into a box and just like make sure that you're actually correct. If you put it back into the box, you'd get x to the 4th, 5x squared y, negative 5x squared y, and then negative 25 y squared. You'll notice these two offset each other, so they're gone. And we get back to the original, x to the 4th minus 25y squared. So you know that you're correct. Okay, this is just to check your work. And then this last one is not possible. It's not possible to factor. The reason is this. Because it's a plus sign, we can't do anything with it. So we just leave it alone. There is a solution, but it's a negative. It's an imaginary solution. So we just stop here right now. Your assignment is to choose 10 problems from the 7.1.2 worksheet and let me know if you have any questions.